All right, ladies and gentlemen, welcome to 6.3 trig functions of any angles. So today we're going to be moving farther around our circle outside of quadrant 1, stuff that we can do in our head, hopefully, even with our hand trick even that we learned last week. All right, so we're going to be looking at three little things here. They're kind of big though. Reference angles, signs, as in positive or negative, and a little bit of calculating how to figure things out. All right, so let's start with this. Trig function of any angle. So we're going to let theta be some angle in standard position with xy being a point on the terminal side of theta, and r is the square root of x squared plus y squared. And that's just the distance formula between a point and the origin. And so here's what we're going to do. So this is in standard position. So my initial side, as we recall, is here. And I don't care what quadrant you choose. I'm just going to choose quadrant 2. This point is x, y. And here's my angle, theta. This is what we mean by standard position again. So initial side, terminal side. And r is this distance right here, the distance from the origin to xy. And we use r because it's kind of like a circle, like a radius of a circle that we could determine from this. And what this does is it now is going to give us the ability to calculate trig functions of any angles by creating a triangle in any quadrant. So what I can do right here is I can create this triangle, and it becomes a right triangle. And this is my x direction, and this is my y direction. And I can do this in any quadrant. All right, so I could have an angle down here where this would be theta. I could have a triangle here where theta's in here. Or likewise, I could come down here and put theta here. All right, but my particular point is in quadrant 2, even though it works for every quadrant. So what this tells me is if I look at this angle right here, let's call it alpha, sine of that alpha, or sine of theta actually in this case is what we're going to look at. Sine of theta is going to be, again, it's the opposite side over the hypotenuse. We'll call this, well, let's go ahead and call it alpha because I don't want to confuse us here. Let's just say this, sine of this angle alpha is actually going to equal the sine of theta because it's the same terminal side. And we know that sine of alpha is opposite over hypotenuse, so it's going to be y over r. And likewise, we can continue this statement going to cosine, where it's x over r, which is adjacent over hypotenuse. Sorry, I didn't specify there. And tangent is opposite over adjacent, so y over x. All right, and it continues to cosecant, secant, cotangent. Obviously, they're just the reciprocals of these. Now, what I want to make a note of, what we're going to kind of eventually get to on our circle, is what would happen if r was 1? What if the distance from the origin to this point was 1? Hence, the name of our circle is actually called the unit circle, which means the radius is 1. Well, if the radius is 1, let's go to a different color here. So if r equals 1, then we get sine of theta is just whatever the y coordinate is. And cosine of theta is whatever the x coordinate is. And then tangent just stays the same because it has no effect on r, or r has no effect on it. It's y over x. Now we should know that because tangent is sine over cosine, so tangent is y over x. And this comes in very handy for us in a little bit. But a lot of what we're going to be doing, or at least some of what we're going to be doing, is dealing with triangles in different quadrants. And you might understand that, well, an x coordinate in quadrant 2 is negative. So if you were in quadrant 2, you'd have a point like -3, 4. And then this y coordinate would be positive, and r is always positive. And this x coordinate would be negative over a positive r. And you would start to understand that sine is going to be positive in quadrant 2, cosine is going to be negative in quadrant 2, and tangent is going to be negative. We'll fill this in just a minute here. Actually, I think I'm going to fill that out right. Oh, no, not just yet. I have an example first. All right, so we're going to let -3, 4 be a point on the terminal side of theta. So we have this. We have the point -3, 4. And this is the terminal side. Technically, this is theta, but we think about creating a triangle right here. And we have -3, we have 4, and we got to figure out what the hypotenuse length is. So we got to figure out that distance. So we're going to call it r, just to kind of keep with the theme here. R is equal to the square root of 3 squared plus 4 squared. Note, I'm not doing the negative because if I square the negative, it just becomes positive. And this way, none of you guys get errors, which some of you guys still mess up your negative signs. All right, so the square root of 3 squared plus 4 squared is 9 plus 16, which is 25, which means my r is 5. So if I said, hey, find the sine, cosine, and tangent of theta, I would just say, okay, well, the sine of theta is, from that last page, it says the sine of theta is y over r. So it would be 4 over 5. Cosine of theta is the x over r. So x is -3. So -3 over 5. And then tangent of theta is y over x. So 4 over -3. And it really is as easy as that. Most people probably will write this as -4/3, which is probably better. It really is as easy as that. Just once you find the r value, you didn't actually need this triangle because I didn't say anything about opposite and adjacent sides and that sort of stuff. But really it just came down to the r value of 5 and then just using those statements that sine is y over r, cosine is x over r, and tangent is y over x. So let's look at another one here. Notice the sine is positive, cosine is negative, tangent is negative. Let's go to -2, -3. So we look at our quadrants here. -2, -3 is down here. And you can draw the triangle if you want, but let's kind of see if we can do this without the triangle. This is theta, obviously. And theta here says, or not theta, but the point here says that r is the square root of 2 squared plus 3 squared, which is 4 and 9 make 13. Well, that's kind of ugly, but it's just a number. So we get the sine of theta is, as defined, y over r. So it's -3 over the square root of 13. And we always simplify this to -3 radical 13 over 13. Cosine of theta is the x coordinate over the r, so it's -2 over radical 13, which again we simplify. And the tangent of theta is y over x, so -3 over -2. And simplify this, please, to -3 halves. So you'll notice here in quadrant 3 that sine was positive, sine was negative, cosine was negative, and tangent was positive. So let's make this definition. You're probably going to want to put this on your circle somewhere. But here is, I told you guys to do this the other day, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And what we're going to do is what we're going to talk about here is if theta is in quadrant 1. So you'll notice that all of the coordinates here are plus, which tells you the sine of theta is going to be y over r. And you remember r is always positive. So sine is going to be positive. Cosine is going to be positive, and tangent is going to be positive because it's y over x. If we think about if theta was in quadrant 2, all coordinates in quadrant 2 are negative x and a positive y. Now we can continue this. This tells me that sine of theta, y over r, well, that's going to be positive. Cosine of theta is x over r, so that's going to be negative. And tangent theta is y over x, so it's going to be negative as well. Now let's think down here for quadrant 3. Just continue this. All coordinates in quadrant 3 are negative, negative. So I say, okay, well, sine of theta is y over r, so negative over positive, so negative. Cosine of theta is the x over r, so it's also negative. And tangent's y over x, so negative over negative makes positive. And then lastly, let's look at quadrant 4. So this is a positive x coordinate and a negative y coordinate. And sine of theta is y over r, so it's negative. Cosine of theta is x over r, so it's positive. And tangent is y over x, so it's negative. All right, so kind of take that to heart, because if I said, hey, eventually what we're going to be doing here is, hey, what's the sine of 150 degrees? Well, 150 degrees is in quadrant 2. So we don't know what the number is yet, but we know the answer is going to be, oops, sorry, not negative, because we're looking at sine. We know the answer is going to be positive for the sine of 150. If I was to ask you to find the cosine of 150, cosine 150 is in quadrant 2, cosine is negative in quadrant 2, so the answer is going to be negative. All right, we're going to use this to our advantage here in just a moment. But first we have to learn something else. We have to learn this idea of a reference angle. And what a reference angle is, it's an acute angle, so less than 90, made with the x-axis and the terminal side of an angle in standard position. And I've actually kind of already referenced this reference angle before in when I looked at this theta, and I made a note of this angle being alpha. This alpha is my reference angle. And what it ends up being is actually what I said at the very beginning. The sine of alpha is the same as the sine of theta. And what that means is we can actually use this very, very simplistic idea to calculate trig functions of all of our special angles. We can actually end up using our hand trick for every single quadrant. So kind of make a picture of this. Let's go ahead and make a couple small pictures. Let's say, if you're in quadrant 1, this angle here, your theta, is the same thing as a reference angle. So quadrant 1 really doesn't have anything special, no special reference angles. So, however, as my picture from before, if you're in quadrant 2 and this is theta, this little angle is, the book calls it theta prime, but let's just call it alpha. And how you're going to find that is you're going to do 180 minus theta. So we're going to say alpha equals 180 minus theta. That's for in quadrant 2. Let's just put my picture right here. If you're in quadrant 3, here is theta. However, this little angle is alpha. And in this case, alpha is going to be theta minus 180. So we want the whole theta, but we want to minus this 180. It's whatever's left over. And then lastly, in quadrant 4, this big angle here is theta, but this small angle is alpha. And in order to find alpha here, alpha is, let's see, it's 360 minus theta. Now, some of you guys are going to be able to do this a lot faster than having to do these little calculations. But this calculation, I think, for a lot of you guys is going to help a lot. To find reference angles in quadrant 4, you take the whole 360, you subtract the theta, you get whatever's left over. All right, so let's look at a couple examples. Use reference angles to determine the following. Sine of 150. So let's break this down. Let's look at what is 150 degrees. So 150 degrees, let's change colors here. 150 degrees is somewhere about there. It's on your unit circle. It is actually one of our special angles. So this is 150 degrees, but I don't have a hand trick for 150 degrees. So what I want to do is I want to find the reference angle. Well, since 150 degrees is on my circle, it's automatically got a special reference angle. And if you use that calculation thing that I had there before, I said that in quadrant 2, I do 180 minus 150, and I get 30. Well, that means that the sine of 150 degrees is approximately, not exactly equal to, well, in this case it is just like finding the sine of 30 degrees. Well, the sine of 30 degrees we know is 1/2. So the sine of 150 degrees is 1/2, but here's where the quadrants come into play. You have to make sure that it's positive half and not negative half. Well, I know in quadrant 2, sine is positive. So sine of 150 degrees is 1/2. Notice I did not take a calculator at all, ever. We knew that the sine of 30 was 1/2. Which therefore means the sine of 150 is 1/2, and we paid attention to quadrant to make sure we got the right sign, S-I-G-N. All right, I've got like 4 or 5 of these, so let's make sure we understand this. Cosine of 240. Let's figure out where's 240. Well, there's 180. This is 270, so 240 is down here somewhere. And as mentioned before, we said if we're in quadrant 3, quadrant 3's reference angle here is 240, the theta, minus 180, which is equal to 60. So it's like finding the cosine of 60 degrees. So what's the cosine of 60? Oh, I used another number where we get 1/2. Well, cosine of 60 is 1/2. That means the cosine of 240 is also 1/2, but it's not, kind of. Cosine in quadrant 3 is negative, so my answer is negative, and now we have the right answer. So the cosine of 240 degrees is negative 1/2. Let's keep moving here. Tangent of 315. Again, 315 is on our circle, so it is a special angle. There's 270, so 315 is right in here. And there's 315. I said in quadrant 4 that we have to do 360 minus theta, so minus 315, to figure out the reference angle. 360 minus 315 is 45. So this is a 45-degree angle. And it's going to be like finding the tangent of 45 degrees. Well, the tangent of 45 degrees, if we drop the middle finger on our hand trick, is the square root of 2 over square root of 2, which is 1. Well, that means the tangent of 315 is 1, but we have to determine is it positive or negative. Well, in quadrant 4, we said the tangent is negative, and therefore it's -1 at 315 degrees. Like I said, I have quite a few of these examples just to make sure we understand everything. But of course I had to put a radian measure in there to not mess up anything. Or not forget anything, I mean. So let's think about 3 pi over 4. Now, some of you guys are still a little unfamiliar with this, but let's kind of think about it. If you just go to your circle, you would know here's 1 pi fourths, here's 2 pi fourths, and here's 3 pi fourths. So 3 pi fourths is right out here. This is 3 pi over 4. Well, now here's where things get interesting, because now you have to do some math with fractions. In quadrant 2, I have to do 180 minus theta. Well, 180 is actually the same thing as pi, because we're doing things in radians, minus 3 pi over 4, is the same thing as 4 pi over 4 minus 3 pi over 4, which is the same thing as 1 pi over 4. Well, sine of pi over 4 is, as we learned the other day, is root 2 over 2. Sine in quadrant 2 is positive, and therefore this answer is root 2 over 2. And that's it. That's as easy as it is. Last one on this page here, cosine of 13 pi over 3. Oh, this one's going to be hard because there's no 13 pi over 3 on my circle. But we do have stuff with thirds on them. So I want to think about this. If I go halfway around my circle, that's 1, which would be 3 pi over 3. If I go 2 times around the circle, that would be 6 pi over, 1 full time around my circle, that'd be 6 pi over 3. And then you go around again, that would be 12 pi over 3. So here is 6 pi over 3. Here is 9 pi over 3. Here's 12 pi over 3. Oh, here's 13 pi thirds. Well, if you notice that we just went around 2 times and then went 1 more pi thirds, you could just keep subtracting 2 pi until you get to this angle, but this angle here is just 1 pi thirds. Well, that's in quadrant 1, which means cosine of 13 pi thirds is actually equal to the cosine of pi thirds. And cosine of pi thirds is a half, because that's the same as a 60-degree angle. All right, so let's move on from this. This is kind of one of those things that we really have to get down. We have to get this down pat. We have to know how to do this. But let's think about other types of examples that you're going to be shown today. We're going to let theta be an angle in quadrant 2. So if we were to just draw that as a reference, here's theta in quadrant 2. And we know that the sine of that theta is 1/3. And we want to find cosine and tangent using some trig identities. And we could use a triangle. We could say, here is this. This would be 1 and 3. And we could figure out this side. We're going to use this as a check to make sure we're right in a second. Or in a minute. So let's put this on the back burner here. So this is the point, or not the point, that's theta. But using the trig identities, I know that I have sine squared theta plus cosine squared theta equals 1. And the reason I'm going to do this one is because I can compare sine to cosine, and I can substitute what I know. Well, sine squared is going to be 1/3 squared plus cosine squared equals 1. This becomes 1/9. If I subtract 1/9, I get 9/9 minus 1/9 is 8/9. And I have to square root. So here's why what we just did is really important. If I square root this number, I get plus and minus square root 8 over 3. I square root of the 9. Now the thing is, it can't be both numbers. Here is why it's important to understand quadrant 2. Quadrant 2, cosine is negative, so it can't be the positive version. So the answer is strictly the negative answer. And then in order to find tangent, I know tangent is sine over cosine. And so I can say it's 1 over 3 divided by negative radical 8 divided by 3, which is actually 1 over 3 times negative 3 over radical 8, right? Multiplying by the reciprocal. The 3's cancel. I get negative 1 over square root of 8, which is actually the square root of 8 over 8, or negative. Right? Because we got tangent is negative in quadrant 2, as is cosine, where sine is positive. Okay. Here's a new identity for us, and I'm just going to kind of briefly go over this one here. These are the even and odd identities. There are 3, basically just mirrored for cosine and secant and sine and cosecant. But what you're going to notice is if I said cosine of the negative angle is actually the same thing as the cosine of the positive angle. So if I said, hey, what is the cosine of negative 30 degrees? Oh, well, this identity says that it's actually just the same thing as the cosine of 30 degrees, which is root 3 over 2. Likewise, I could say, hey, what is the sine of negative 150 degrees? Well, that would just be the opposite of the sine of 150 degrees. And we figured out the sine of 150 degrees is what, half? So the sine of 150 is 1/2, but now it's negative 1/2. And we can just use this in any way. So tangent of negative, let's go 45 degrees is the same thing as the opposite of the tangent of 45. And we know the tangent of 45 is 1, but it's negative, so it's negative 1. Okay, really simple identity. We don't always use it like every single time, but it comes in handy. Okay, that's going to finish us off for today. I hope that enlightened you a little bit. I will see you guys tomorrow.